Thank you, Narayanan sir, for sharing your valuable knowledge about Ashtavaidyas in shaping in shaping the health culture of Kerala. Now I humbly request Dr. P. Ramanohar sir to honor Dr. Narayanan sir with a token of gratitude. Welcome, sir.
We have Dr. V. Ramanathan with us. Dr. V. Ramanathan is a physical chemist working in the Department of Chemistry of IIT BHU Varanasi. He carried out his postdoctoral research works in University of Stuttgart in Germany, University of Basel in Switzerland, and Seoul National University in South Korea. He obtained his PhD in physical chemistry from IIT Kanpur, India. His area of academic research are Raman imaging, spectroscopy, laser spectroscopy, and computational chemistry. His other research interest lies in studying the scientific heritage of India, Indian history, philosophy, Indian traditional medicine, Indian classical music, and languages. He is a Fulbright scholar and a core committee member of Indian National Young Academy of Science. There is many more to add onto his card. With due respect, let me welcome Dr. V. Ramanathan to give a lecture on the topic Indian Knowledge System, Science and Ayurveda. And he will be covering the following key points: scientific temper in the Indian tradition, contribution of ancient India to development of science, and scientific aspects of Indian medical heritage. Welcome, sir.
It's my pleasure to be in this place. All thanks to one of my inspirers, Professor Ram Manohar ji, to speak on a topic which is also not only close to my heart, but something that this place is also cheering up for and battling hard to establish it as a mainstream. So the topic that I will be speaking to you for the next 2 hours or so is on scientific heritage and temper, scientific temper in ancient and medieval India. Scientific heritage part, okay, it's we all can see what has been our heritage, but I have deliberately was glad to see in the invitation email asking me to talk about scientific temper also, because right from this state we had a lot of inputs in preparing what is called as the 1981 document on scientific temper, which got further revised some 10-15 years later, and as late as 2011 or 12 we had this Palampur declaration on scientific temper. But this entire narrative or discourse is kind of, I would say, hijacked by a specific school of thought. Before me you had this wonderful presentation by Dr. Nambi Narayanan, who gave us the living tradition of the Ashtavaidyas from this region. Now, without having the term scientific temper, throughout his talk he didn't use the word scientific temper, because it did not require that word to be used to express the scientific aspect of this medicine. But we are pushed to a state where we'll have to remind, okay, had there been not scientific temper, would there have been this Ashtavaidya family? Would Dr. Narayanan would be standing before us and talking about the medicine that had kept the civilization healthy and alive for so many thousands of years. So something that we need to sit back and think, which we have not thought till now. Why that scientific temper has to be only master-headed by a specific group of people. So my talk is centered around that. Let's see how it goes. This is a broad outline in which I have divided my talk for the next roughly 90 to 100 minutes, is to see the whole dialogue, how it starts in Europe. So what is the stand that church had taken versus the science that was developing in the medieval, in the Renaissance period in Europe? How did they have in their civilization some things like this necromancy? How did science look at it? How did church look at it? Then I will, without giving much detailed exposition on that, quickly move on to the scientific temper in the Indian tradition, of which, of course, you had this one beautiful exposition by Dr. Nambi. I'll take a rather academic route there, because how is the scientific temper entrenched in our society, in the intellectual part of our society? That is through something we cannot ignore, what are called the Pramana Shastras. So although I am not a student of philosophy, neither I am an expert in that domain, but unless we see them as the bedrock of our epistemology, our approach towards gaining knowledge, I don't think we'll be in a position to understand the totality of the Indian way to approach knowledge. Then give you also an example of Tantra Yukti, which Ayurvedic people are very much familiar about, but something that non-Ayurvedic people should also know what this stands for, this Tantra Yukti. With these two just textual illustrations, I think the scientific temper that was in vogue in the Indian tradition will be made clear. Then I'll move on to the third section, which is showing you some glimpse of the scientific heritage by taking few examples from maths and metallurgy and possibly biology. Then I'll conclude with spending a few minutes on the way forward with some concluding remarks. So if you look at the scenario in Europe, and when I say Europe, it's in the last millennia, say 1100 till 1600 or so. You had this Greek, I'm not going deliberately not going back to the Greek period, something like Aristotle or Plato or Ptolemy, because this is not a whole talk based on that. But much of the European ideas towards approaching nature, knowing the nature, approaching knowledge, gaining knowledge, is inspired from the Greece, the thought that emanated in the Greece, in the Mediterranean region. Fast forward it to the second millennia, that is where the most of the action happens. We get to see at least happening in that way, because the stronghold of the theological structures gets entrenched. Mind you, 1,000 years of existence of a theological structure comes with its own crystallization, comes with its own dogmas, and that's when you have this counter-emanating thought. And what is the altercation that happens between science that is newly emanating from there, and partly new, partly also learning from various exchanges that they had with the other cultures? What did that clash, what did that schism give rise to? This is a very beautiful picture, and this is the trial of Galileo by the church authorities. Okay, why Galileo? Because Galileo, not just standing alone, but he had the tradition of looking at Johannes Kepler, Tycho Brahe, all those people's observation, then passed on to Galileo, who kind of was a predecessor to Newton's formulating the laws of motion in a mathematical way. So, although Tycho Brahe and Johann Kepler were not the prime target or focus of the church, when it came to the Galileo's time, he was kind of, because he was very radical in his pronunciations about the results, he was the prime target of the church. And that is a well-written history. The Western history also doesn't deny that. So it was a big schism that happened between the school that Galileo was representing. Basically, it was a shift from the geocentric worldview to what he was trying to see as a heliocentric worldview. Till then, the belief was that the earth is at the center. We human beings are the center of attraction for everything. Suddenly, Galileo comes, not just his own observation, but observations from his past thinkers, and he challenges that theory, says no, earth is not the center really, the center is really the sun. And we all know this is school textbook history that I am talking about. But this brought about a huge rift in the society, right? So much so that he was persecuted. So it led to the level of that. So you had arguments from the Galilean school of thought, you had counter arguments from the church, and ultimately we know which faction had won. So why am I bringing this well-known history in my talk here? Because in all the subsequent intellectual documentation that has happened, at least in our country, it has borrowed lock, stock and barrel the ideas of this confrontation between the so-called science school of thought led by Galileo and the theology led by the church. They had some problems between them. Whether those problems are good or bad is not the discussion that I'm trying to focus on. They had genuine problems in their society that they dealt with. Now, our thinkers somehow, for want of better technique or better tools, they got inspired by that altercation, and then whatever pedagogical method that had adopted to teach that altercation to at least current generation in their countries, those pedagogical tools were borrowed, imported lock, stock and barrel. Now this has got severe problem when it comes to our society. Because all said and done, we can clearly demarcate between what is religion of books and the religion which are not based on specific book. In other terms, Abrahamic religion and non-Abrahamic religion. And for all said and done, the country's vast majority has been non-Abrahamic right from its early history onwards. So the problems that an Abrahamic religion faces against this so-called rationalistic science is definitely not applicable for a non-Abrahamic context. Okay? But unfortunately, the so-called paragons of scientific temper made this fundamental blunder. I mean, this is the irony that laughs at our face in a very glaring way. This basic difference that the non-Abrahamic religious approach is very different to nature and reality vis-a-vis the Abrahamic religion's approach to reality. Again, I am not making any judgmental remarks here that which is good or which is bad. That is not my concern of the point that I am trying to drive. All that I am saying is system compatibility issues. There are some system incompatibility issue in Abrahamic context with the scientific findings. People did not even question whether that kind of a compatibility issue will it get transported in a non-Abrahamic context or no. Okay, I want you to keep that point in mind, because that's where this kind of cartoons emanate. That science, when you have science is looked upon as, even when you have tons of evidence, doubt what you see. There is no question of andha-bhakti or andha-shraddha in the context of science. I am sure if you talk to Professor Ramanohar or Dr. Naminarayanan, they will definitely give you thousands of evidences where our Granthakaras or our Vaidyas or our Vaikyanikas did not propagate anything without testing. It is, I mean, this is not a match fixing just because I know them. Independently you can talk to them and say, they would go to the extent of writing it in black and white in the letters. They say, I am narrating this in this text what I have tested and I have found correct. Not something that I am carrying forward from the past in a blind manner. Is this not questioning attitude germinating in our head, in our kind of in our thinking? Vis-a-vis the religion you see here. Even without a single piece of evidence, believe in what you can't see. Now, instead of answering, I mean, I leave it to you to think and come to a conclusion for yourself. Is it applicable to a non-Abrahamic faith? So, even science, if you do not, because until the 17th, 18th century, good part of even 19th century, even in the Western context, there was no clear-cut demarcation between science and philosophy. So much so that even to this day we award degrees in doctorate in philosophy, even though the subject that is being studied is science. So you see here, the philosophy questions that may never be answered and religion answers that must never be questioned. So what I'm trying to highlight here is the dichotomy that exists in this context of Abrahamic and vis-a-vis science or philosophy. And definitely we can come to a conclusion right away that such a kind of black and white, such a kind of contrarian viewpoints are not applicable in a non-Abrahamic context. I hope all of you are agreeing with me, and with that consensus we can move ahead. I mean, this is, if I extrapolate it slightly, maybe I'll have it in the next slide, yes. So now you see things like this kind of narratives being spun in the popular media. Like you see here, that this again cartoon depiction. Don't take the cartoons seriously, but this is just an idea that I wanted to convey through a medium. You take this earth, or this earth which is having the life, which is supporting life in the entire visible universe that the scientists are able to lay their hands on. There's a Goldilocks conjecture people have made, that if there is an optimal distance from the sun, like the Earth's distance from the sun, that can support life. So the astronomers are, the billions of money are getting pumped to see which other galaxy has got a sun, and that specific distance, it's called a Goldilocks distance, within which they are trying to locate any planet and see if that can also support life. But all said and done, till now there has not been any success. We have only one unique Earth. So you have this two faction, one which says this is the evidence for creation, the creationist theory that has again evolved from the Abrahamic theology, whereas the science again, it says no, this is the evidence for evolution. So what I'm trying to tell you is that even if the theological constructs, theological frameworks evolve in a in the Abrahamic context, this friction between these two factions are always existing. That is what I'm trying to drive home the point here. And if we ask the question, internalize it for our context, when I say our context, the Bharatiya context, which is primarily and fundamentally non-Abrahamic, these kind of dichotomies are artificial. They are kind of, they do not belong here. And you see, in the same context, I put probability also. Okay. What's the Malayalam word for probability? Sadhyata. Very nice. Maybe in the next slide I'll come to that. Is this sadhyata pramana, at least in Ayurveda? Never. Sadhyata can never be a pramana. But for our Pauranikas, actually it is Sambhava. Sambhava is also equivalent to Sadhyata. Sambhava is taken as a pramana, in fact, very interestingly, for the Pauranika, and not even the Itihaskara, but Pauranikas take Sambhava as also pramana. But you see the Western world, purely the science part of it. You had this theological hold, then you had this schism, Galileo versus the church, but the classical science got established. Ultimately, the science war seems to have won, because that is where we had Newton, Huygens, and the classical physics got its root. Until the second half of 20th century, where you had this earth-shattering discoveries, like discovering the electron, discovering radioactivity, discovering photoelectric effect. Those things demanded new answers that even neither the theology nor the classical science could answer them. Those of you who are from science background will be able to understand what was the phenomenal contribution by Max Planck in creating something called as a quantization of energy, that is through introducing what is called Planck's constant, which is used by Albert Einstein in 1905 to describe what is called photoelectric effect, which was discovered in 1888. So in 1905, Einstein uses Planck's constant quantization of energy to get, and he ultimately wins a Nobel Prize for explaining photoelectric effect. But the paragons of classical science themselves, they did not understand or embrace the concept of quantization of energy for a very long time. So much so that in 1920 they had a conference which is called a Solvay conference, where the biggest mind of all parts of the world which are thinking on this new emerging field met together and they kind of came to some kind of a consensus. So what I'm trying to highlight here is even that science which emerged as a product of the friction between the church and the Galilean school had problems, initial kicks in accepting the veracity of the new field called the quantum physics. Of course, now we have evolved all the way till quantum field theory. That's a different story altogether. But what I'm trying to drive home the point is this acceptability of views keeps on evolving. And if something that has emerged out of this fundamental friction, one has to be one has to take note of this kind of trait that this has. Having given you a very brief idea of what has been the approach in the Western world, so let me now jump to this thing of what was this condition or what was scenario in the Indian context. And as I said, we cannot approach the Indian way of thinking or the Indian, what we call technically as Indian epistemology, without resorting to what are called these pramanas. They are the means of acquiring knowledge. There are technical way to define them. I'm not bothering you with the technical definitions of what these pramanas are. I mean, the etymological roots of them. I'm not going to bother you with all those technical details, but I'll give you a ringside view because, as I said, I'm a student of modern science. I'm not a student of Sanskrit or philosophy. So the way I look at it, I'm trying to present you this, what are called the prominent 6 pramanas. First, it starts with pratyaksha. Pratyaksha, as you all know, it is something that we can directly access through one of our 5 senses or one or more of our senses. So normally when we see a fire, we also see smoke associated with it. So this is the pratyaksha jnana that happens. When we see something, predominantly through our vision, but need not always be through vision. It could always be through any other senses. Like we say that a food is stale. There is nothing to see there. There is nothing to feel there. There is smell. Our smell is able to say the direct presence of certain microbes which have brought about the degeneration of the freshness of the food. So that is the pratyaksha, that is a first valid means of acquiring knowledge. But then there are instances where you make an informed guess. The English words that I'm using for the Sanskrit terms are only approximate translation. The exact Sanskrit term here is anumana. Anumiti karanam iti anumanam. But the counterpart in English is informed guess, or what in science we use it as inference. But inference is not exactly related to anumana, although people interchangeably use it, but that's the handicap of the human languages. What is anumana? Even the normal colloquial Malayalam word also we'll be using anumanam, right? It is to make a guess, but it's a qualified making. That's why I'm calling it an informed guess. What is it? Very roughly, if we happen to see the smoke, we will immediately be able to say that something is burning, that fire is there, without even having seen the fire directly through our eyes. So, and how is it systematically established? Through these panchavayava. I mean, there are 5 aspects to it. I hope it's clear. It is this is the 5 aspects through which this process of inference happens. There's pratigna, hetu, drishtanta, upanaya, and nigamanam. So what is the pratigna? That is something that we need. What is the objective of our this process here? To infer something. And in this case, to infer fire. Right? How do we do that? What is the hetu? What is the medium through which we approach that? Because we are directly seeing the smoke. What is the drishtanta? Immediately we run our memory database and we say in the past I have seen smoke, wherever smoke is there, fire is associated with it. So I make that kind of a mapping, mental mapping. And then upanaya. After doing that mental mapping, I am able to relate that mental map to this particular thing that I am seeing in front of me. And hence I am coming to a conclusion that there is fire, although I do not see the fire directly, because I see only the smoke. So this is the whole process of Anumana, where this Nyaya people they go into threadbare to establish it. And let me tell you, this process is entrenched in no matter what scientific domain our ancients were involved in, Ayurveda or Dhatu Shastra or Nirmana Shastra. Because many things we don't directly see, but we will be able to infer them. And for that matter, the modern science, whatever instrument we use to measure, normal thing, temperature, thermometer that we use to measure, is a very good example of Anumana. Why? Because normally how a thermometer works, I'm talking about this analog thermometer, or even the digital thermometer also, you can take it. We put it to a hot body and we read a number and we say that this is this much hot. But we do not calibrate it. Somebody else has calibrated it, has seen it directly, the thermal expansion of mercury at every 1 degree rise of, say, the heat. We have not done that. That we are using it to infer it. So the entire scientific data collection that happens through instruments intervention, when I say instrument, it need not be just one, it can be many instruments in succession. At the end of it, the data that we get are all the process of Anumana that we are actually doing, right? So these are the two things. Then the third is, if I tell the name, you will be able to identify it. But the moment you see the third picture here, this picture that I'm talking about, what does it strike you? Somebody said snake. Did I right? Did the snake strike your thought process the moment you see it? Actually, this is not a snake. This is an electric eel, right? But many times we don't see the electric eel. What we have seen is a snake. So our mental faculty does this pattern recognition and throws that result out, which is very much familiar to us, where the knowledge is already established in our mental space. And that is through our various other, it could be Pratyaksha or Anumana, but that was, we know how the snake looks. But when we see something new, at the first instance we may call it as a snake, but then when carefully if I see, okay, fine, then it has got some extra features here. It is perhaps the python will not have this much small length. So we make such clarifications. But our base is something that we had known. We are comparing it and then we are learning something new about this new creature. So this style of doing is called upamana. Simile, something that is similar we are already knowing, and through that something known we are trying to reach the unknown. Okay? So Pratyaksha, Anumana, Upamana. This is a slightly more technical, more nuanced thing for non-darshan people, but I'll try to keep it simpler. Because it's very interesting from science point of view when I try to understand it. The fourth is Arthapatti. Arthapatti means it is among the different schools of philosophy in India, it's the Vedantins who will take this more seriously. The other school, for the Nyaya people, this is exactly similar. This Arthapatti is similar to Anumana. So for them, they don't make this distinction. But it is interesting to see the fine distinction between this and this. If you recollect, in the context of Anumana, I said we have a past knowledge of having seen fire and smoke together. That's why later, when we see the smoke separately, we make a guess that perhaps something is burning, fire is there, because of which smoke is coming. So a past knowledge about association of fire and smoke is there in our mind, in our mental faculty. But in the case of Arthapatti, what happens is, the classical example, traditional example that is given is, there is somebody called Devadatta, and you are observing him, and he doesn't seem to eat at all during the day. Obviously, night time you don't observe him, you go to sleep, and you come the next day, and again you start observing. He's under your radar scan. So Through some means you put a CCTV, but during the daytime. The CCTV also works in solar power, so that sun sets, the CCTV doesn't work. So you are not in a position to see what happens in the night. But in the daytime you are seeing Devadatta is not eating at all. But at the end of the day, after several weeks, several months, he seems to remain as healthy, if not grow even fatter. He doesn't seem to become thin. So what do you do at that point of time? You make a conclusion that perhaps he is eating in the night. But you have not made any observation. You have not put a CCTV camera under him in the night time. You are not seeing him directly in the night time. Okay? So that is a thin difference between this Anumana Pramana and the Arthapati Pramana, where you do not have the direct access to the fact that something is happening without our observation. But the end result definitely says that Devadatta cannot stay alive, cannot be remaining healthy if he is not eating. So this way of finer informed guess is called Arthapatti. So we have covered 4, Pratyaksha, Anumana, Upamana and Arthapatti. 2 more vitals are remaining, and one of them is absent here. That is Anupalabdhi. Okay? We say in this room, Mata Amrita Anandamayi is not here. Actually speaking, if you technically analyze it, it becomes very difficult to prove something's absence. Or say, our Honorable Prime Minister Narendra Modi is not here. How, in the case of going out to list out things that are not here, it's an infinite list. But when we are doing it, we are conveying some confirmed knowledge that Narendra Modi is there. He is there in some place on this earth, which I do not know. But what I know is I am perceiving his absence here, which is also called Abhava or Anupalabdhi. Experiencing something's absence is also a valid knowledge. And this was put into action much more during the COVID time. Because you want to see whether it is a bacterial infection first or a viral infection. So doctors will conduct some pathological studies to rule out whether it is a bacterial infection or not. So they say that the bacterial infection is not here. So something's absence, Anupalabdhi, is also as important as detecting something's presence. Okay? And this, the Western approach, it was taken up much more seriously in the last 100 years, and people have done some wonderful work on exactly this Anupalabdhi part alone. So much so that there is a dialogue between Whitehead and Russell. And the title of the paper itself is "There is no black scorpion falling on the table." That's the title of the paper. And it's exactly an exposition of, that's the first stumbling where the Western people stumbled upon this Abhava or Anupalabdhi part. But in this Ayurvedic context also, the Abhava is used in a very, very elaborate way. And the 6th Pramana is a Shabda Pramana, or in context it is also called Agama Pramana. There are 2 aspects to Shabda Pramana. One is Laukika and Alaukika. I will not bother about the Alaukika part. In the Laukika part, the Shabda Pramana, the way I understand it is the words of wisdom that are already known in the context, in a particular societal framework. It's like today when we want to write a research paper. Suppose on say, after getting inspired by listening to Dr. Narayanan's talk, I go back to write an essay on Ashtavedya family tradition of Kerala. But I am not the first person to do that, because he just spoke to us saying what all documentation has happened. So I'll have to refer to all those past literature. And when I'm referring to them, in the first paragraph of the introduction chapter, I will not question the conclusions reached in those works. I will take them for granted. I'm not going to relive those intellectual processes. They have done that labor, and I'm taking it for granted now. That taking for granted and building on that is actually Shabda Pramana, which is what is a standard tenet in even the current practice of writing research papers. Especially in experimental science, if somebody has worked on, say somebody has synthesized some nanoparticle, okay, and you are interested to look at the medicinal property of this nanoparticle. Being an Ayurvedic people, Ayurvedic community, you are not going to repeat the synthetic process of making those nanoparticles. You are not going to repeat that experiment part of this work at all, because you're taking it for granted, even though you have not verified it. It has come published and come in a public domain. So you are assuming that this knowledge is a valid knowledge. You are taking that and carrying forward with whatever intervention you want to do. This part of taking forward is what is called as the Shabda Pramana. Okay? So this is a very brief nutshell that I'm trying to give you in the last 10-15 minutes about the fundamental epistemic approach that was entrenched in this Indian thought right from early on, be it in any Shastrakara that they had practiced or written the Grantha. Without these pramanas being taken into account, they did not proceed further. Mind you, 6 is not a very magical number. You had this Lokayata philosophy, which believed only on Pratyaksha. It is called Charuvaka. Charuvaka. So it's something that is very pleasing to listen. I mean, they have their own ways of impressing minds. I mean, the very famous quotation is there, no, that Yavat jivet sukham jivet rinam nitva ghritam pivet bhasmi bhutasya dehasya punaragamanam kutaha. It's a very famous Lokayata saying. So they believed only on Pratyaksha, and rest of the Pramanas and all are good for nothing for them. Then if you actually see the Vedantins believed in 6 Pramanas. If you go to Pauranikas, they will believe even more number of Pramanas. If you come to specifically Ayurveda, yes, over and above that they will have Hetva Bhasa. Hetva Bhasa becomes very important for medical practices to proceed over and above these Pramanas. Okay? So what I'm trying to drive home the point here is, without this kind of a logical, firm, scientific, basic grounding, did we have any kind of an intellectual activity in the past? I mean, do we have any Granthakaras who say, fine, I heard it from the sky and I'm writing it down for you now? I'm not belittling their Ashariri ability to get the Ashariri Shakti. I'm not belittling that. But none of our Granthakaras actually write it when they start a Grantha in this manner, be it any field. Because this was the basic framework with which they had approached. And that framework was further crystallized in another, not exactly a text, but another way of approaching the body of knowledge through this work called Tantra Yukti. And for the first time, we get to see this Tantra Yukti in the written form, prominently in 2 texts, Charaka Samhita, as well as in Arthashastra of Kautilya. Now, whether this Arthashastra addition of Tantra Yukti in Arthashastra happened later or not, that's again a different debate. Because in last time also from the same podium I told that India should actually go for filing a lot of Guinness Book of World Records. One of them is maximum number of our texts of which we do not know the author. Maximum number of texts which are not dated properly. Maximum number of controversies to authors whom we know that they have written that particular text. For Nagarjuna, for that matter. To this day, it is not very clear how many Nagarjunas were there. Because there is a controversy that there is a Buddhist Nagarjuna is very different from the Rasashastra Nagarjuna. I mean, the list is so many that India can really go and file case, and we can feel proud in that aspect that we have this Guinness Book of World Record for our ignorance. I mean, this is a very, with the pain that I'm giving you the sarcasm, that despite being so much great, we have not bothered to really document it we have not paid attention to that. And rather, there have been controversy that has spun, which has belittled, which has kind of created confusions in the minds, so that we will be bothered only about the confusion and not at the crux that is getting on. So why I brought into this was, there is a controversy that Kautilya was not one. The Kautilya that we associated with Arthashastra was a different Kautilya, and the text of Arthashastra itself grew like a bark of the trunk of a tree. It has so many this concentric circles. So like that, the Moola Grantha was different, and at every different centuries, new Adhikarana was added to it. So, I mean, these are all serious academic works that people sitting in high power have written. And we have not bothered really practicing of Ayurveda. Like if you ask Dr. Nambi or Ramanohar, they are bothered of how to treat the patient. To hell with all these kind of where the Charaka Samhita, Charaka is not even a name of somebody. But if somebody is creating a whole PhD thesis on was Charaka a man or a woman, gender oppression during the period of Charaka because Charaka was a man. I mean, there are conferences and scholarships given in such kind of, I'm not saying exact, these are examples, but how the attention is diverted. So much so that real people who are stakeholders, anyway, they will not be bothered about it because their concern is to treat the patient. But you shift the question in the academic world and try to say, okay, these are all nothing, they are all bogus. I'm trying to give you the picture of the strategy with which we have to defend our own past science. That's what I'm trying to keep it in before you. Tantra Yukti is a phenomenal work. I mean, there should be a separate session that I think Amrita School also has got some chapter, some works or some courses on Tantra Yukti, if I'm not wrong. I see. That's at least you are giving that much. That is good. At least the students of this university will know what the Tantra Yukti means. Otherwise, this text, this Tantra Yukti name can mean anything, something to do with Tantra, Buddhist Tantra, and all. They will think. At least your students will be aware what Tantra Yukti is. For those of you who do not know what Tantra Yukti is, to give you a very brief nutshell, there are around 36 salient features that this talks about first. What is the Prayojana? Who is the Adhikari? What is the Vishaya? What is the Sambandha? What is Upadesha? What is Apadesha? What is Sandesha? Like that, there are 36 such kind of words are first dealt with. And then it says how a text has to be written and how a text has to be read. So it is like a meta book. Today we use that word meta-analysis. It is a meta book to approach a technical subject, approach a technical book actually. Both for reading as well as for writing. Where, in the beginning of the Tantra Yukti itself, and that is dutifully followed by many Granthakaras. This Anubandha Chatushtaya that is normally talked about. The Anubandha Chatushtaya, at least among those 36, later you will find all those things, but first you should state the 4. What is a Vishaya? Who as an Adhikari I am able to say this? What is the Sambandha? And what is the Prayojana of this particular Vishaya that I am trying to establish the Sambandha being an Adhikari? And this is nothing but an abstract today in any scientific paper that you take, try to communicate through a peer-reviewed journal. You need to have an abstract. And that abstract has to succinctly capture what has been your result, how have you obtained it, what's the application of that particular result. Of course, Adhikari part is taken care of because you write the name and the affiliation. That takes care of the Adhikari part. But here this is laid down as a step of practice thousands of years back. Can it emanate without having scientific temper in it? I mean, I leave it to you to answer. It's a rhetoric that I'll be again continuously asking, because even if you read the 2011 Palampur Declaration of Scientific Temper, those people have perhaps not even read even a single works from our traditional science. So, I mean, one of the requests will be to Ramanoharji to call these people who are involved in this Palampur Declaration for such workshops. They will be benefiting a lot. Otherwise, it will be like, our echo chamber. So, that is something that is need of the hour, and we need to organize something. We need to do it at the national level also. So you have this Tantra Yukti as a brilliant, not just a pedagogical tool, but something that with which a technical subject has to be written. Mind you, this is a technical subject. It is not a prescription for Kalidasa to write Raghuvamsha or Meghaduta. No. This is something, if somebody is writing a technical text. And there are, n number of technical texts that we have with us which follows the Tantra Yukti style. Now again on the scientific temper. This is a book called Shishyadhi Vriddhida Tantra. Shishyasya dhihi tasya vriddhihi यह ददातु tat shishya dhi vriddhi da tantra. Okay, written by somebody called Lalla, coming from Kashmir. Now, luckily for me in the slide, the date is not there. But those of you who are planning to sleep, to wake you up, I just want to quiz you. Can you guess what is the rough date of this, not the publication, but this guy Lalla? Rough date. Give it a guess. I mean, nobody is marking you here. Shishya Dhi Vriddhi Da Tantra by Lalla from Kashmir. Sorry? Bit louder, please. 400 years, 200 years of error bar. Again, it's a good one. Luckily, I mean, you didn't say between 0 to 2024. But yeah, I will know that guess was correct. Lalla is from 10th century Kashmir. 10th century. That is what is accepted date for the Lalla. And in this you get an Adhikarana, chapter number 20, which is called Mithya Jnana Nirakaranam. Mithya Jnana Nirakaranam. Okay? And this is the index pages screenshot that I am showing you here. This Lalla is actually an astronomer, and he writes the book to make the Dhi Vriddhi of his astronomer students. So in that he dedicates a whole chapter on what has been a wrong knowledge or a false knowledge that was prevalent in the society. Okay? See, any society will have some kind of a practice that gets degraded into baseless logic. To give you one simple example, how many of you are from microbiology background? Only one. Okay. Typically in the microbiology lab, because they maintain cell cultures, it is very important that you don't get the slippers, you put the slippers out, you put special slippers, you put gloves and all, and so that you do not contaminate the stuff. And if it is working especially in infectious microorganisms, you don't get infected also, so that you protect yourself. But typically what happens is, this gloves, the moment you step out, before stepping out, you need to discard those gloves. Otherwise, what you are doing is, with those gloves, you are handling the door's knob. The microbes are in that particular gloves, and you are contaminating those knobs. Anybody else who is handling that knob without a glove is perhaps coming in contact with that particular microbial organism. Okay? But this part of thought never goes. In the microbiology lab, we need to put the gloves. So even if you have to go out for using the washroom, I'll go out with that gloves, handle all the doorknobs and come back. So this is Mithya Jnana. So what I'm trying to say is that even in modern science, practicing modern science, you have many such kind of practices which are arising because of Mithya Jnana. So in his time, by 10th century also, there were a lot of Mithya Jnanas, and here is a guy who comes and writes a chapter and kind of does a Nirakaranam of that. So will it not reflect the existence of scientific temper in the society for somebody to observe what are the Mithya Jnanas? Let me do the Nirakarana for that. Okay? And this is happening in 10th century, almost more than 1000 years back. One of the Mithyas. Asuro yadi mayaya yuto niyato atigrasati iti te matam ganitena katham salabhyate grihakrit parva vina kathanchana. So the first line is Mithya Jnana, the second line is a Nirakarana. What does the first line say? It is a popular belief that even now that belief has still stuck for, I don't know, for reasons unknown, that Grahana Kala, eclipse, when it happens, normally the folklore or the normal thing to describe it is some asura is coming and swallowing the sun or the moon. Right? Now this is a pictorial way of, or one way of communicating the idea. But that has stuck. So this Lalla is questioning that. Asuro yadi mayaya yuto niyato ati grasati iti te matam katham ganitena katham salabhyate. How is it that I am able to predict when that asura is going to come and swallow? If there's, so you see the level with which he is questioning and refuting the Mithya Jnana that was present in his time. One more example. I'll not bother you with that. Kamathadibi rudhritamahi yadite kena dhruta nabhasthitaah ata esham viyati sthitir yadi kshiti golasya tu kena varyate. Means, again, the first line is the mithya jnana, nirakarana comes later. The second line. What it says, Kamathadibi rudhritamahi. There's a belief that there's a tortoise resting, and on its shell is the earth that is being situated. Now he asks the question, if the earth is situated on this Kamatha's shell, where is that Kamatha sitting? You have an answer somewhere else, which comes that it is sitting on the 4 elephants that are on the 4 corners. Then it's like an ad infinitum, infinite regress. Where are those elephants resting then? If you come up with one more object, you say, where is that object resting then? So he raises this kind of a question and says, if it is the idea of gravitational suspension, he doesn't use the word the gravity, of course, but the concept of this earth being suspended or getting suspended in the space by its own volition is what he's trying to drive home the point. So please again recap and say, could this have been possible without the entrenchment of scientific temper in the society? You had Tantra Yukti and Pramanas coming from thousands of years before Lalla, and again the same thing getting carried forward to Lalla, right? The other aspect of this Western approach vis-a-vis the non-Western approach. Today that is a very much of value and significance, relevance today, especially in this part of Kerala that we were discussing. That even February is not up, but still we are experiencing such high temperatures. That is because of this egocentric approach that is called the anthropocentric approach versus the ecocentric approach. What are these two? Now, for the Western science, which has its roots on the Western theological constructs, philosophical constructs, its human is the pinnacle of the creation. Everything else around the human is meant for the human's consumption, exploitation, and human's merrymaking. That's why, I mean, this is the economic models also that had come up are all carrying forward the same ideologies. Okay, vis-a-vis what has been the Indian approach? That human being is part and parcel of this entire creation. There is nothing special about this human's approach. It goes a step higher because he has got this viveka. It is his responsibility to see to it that the balance in the ecological surrounding is not disturbed. It takes upon itself. I mean, one of the very controversial and very much negated document of our country, Manusmriti, being infamous for various wrong reasons, if you see, it devotes chapters after chapters to lay down what should be the conduct of human in general public, how a lake should be preserved, how a river should not be polluted, how public places should not be polluted. So with that, I can clearly see the relationship with your surrounding, how it even affects because of one approach that the West adopts and the approach that we had adopted. Now, having given you the glimpse of what was the scientific temper, where do we stand, and by now I think you should be in a position to answer about the strength of our scientific temper. What I'll do next couple of minutes is to highlight some of the scientific heritage part. What has been the achievement? Again, it will be a very superficial highlighting overviews, not very deep, although in few topics I would like to take you to some depth. Coming from Kerala, again, you have this Vararuchi, who was part and parcel of your land. He had invented something called Katapayadi system, which is still followed at least in music circles, naming the Medakarta Raga. I'll briefly tell you what this Katapayadi system is, and there's a reason why I included it, because the last presentation Professor Ram Manohar presented, which I had to continue the same thing. I couldn't present it at that time, so I thought I'll present it now. So you see here, the Katapayadi is a very elegant system. Nanyavachascha shunyani sankhya katapayadayaha mishretu pantyahal sankhya nachachintyo halaswara. So na and nya, they will take the value 0. Nanyavachascha ach. Ach is a pratyahara. Ach means all the vowels. So all the vowels will take again also 0. Sankhya katapayadayaha. Kadinava, tadinava, padipancha and yaralava will take this. Okay. Sankhya katapayadayaha. Mishretu pantyahal sankhya. Suppose you have a samyukta akshara. Samyukta. So yukta, you, half ka and ta. That ka should be ignored and ta should only be taken. Mishretu pantyahal sankhya nachachintyo halaswara. So if the swara comes anywhere, you don't have to worry about the swara. So ka, ka, ki, ku, ke, kai, ko, kau, everything will be one, no matter what swara is associated with it. And similarly, vyanjana with a halanta should not be considered. Nachachintyo halaswaraha. So now if you see, Ayur Arogya Saukhyam Krishna. This is the very famous line. That's why I put this picture also, which this, by the way, I took it from the Amrita's website only. Somewhere the credit is going behind it. This is the Phalashruti or the last Charama sentence of Narayaniyam. Ayur Arogya Saukhyam. But actually this is the Katapayadi code. So if you use this table and decode this, so A occurring independently, so it is 0, Ya is 1, Ra is 1, Ra is 2, Ra is 2, Gya is a Samyukta Akshara, forget Gya, take only Ya, which is 1, Sau is 7, and Khyam is again a Samyukta Akshara, where Kha has to be ignored, only Ya has to be taken, so it is 1. And in convention, Ankanam Vamato Gatihi, so you read the number from right to left. So it is 171210. What is this actually? This is a line from the famous, okay, corresponding number is a day when the work was completed. That is, it is 17,12,210 days had gone by after the Kali which had started on 3102 BC. 13 February 3102 BC is taken as the start of Kali age. So from that time, 17,12,210 days have elapsed. So this will correspond to 3rd November 1585. So you have a time stamp. So why I am highlighting this is many of these so-called famous historians, they always blame that Indians don't have a history of timekeeping. They do not really have the sense of history, linear history. But there are instances, I mean, even in several astronomical texts as well as, I have not bothered you with Bhuta Sankhya system and all, because there again, the Granthakara, like the Siddhanta Shiromani Bhaskara II, he says, Rasaguna Purna Mahi Sama, Shakanrapa Samaye Bhava Mamotpattihi, Rasaguna Varshena Maya Siddhanta Shiromani Kritam. So he says, when I was born and when this text was composed. So the timestamp was already there, but the timestamp was given in a versified manner. Here I have giving you the example of the Katapayadi scheme of numeral coding. I'd like to spend a few minutes on this aspect of mathematical beauty, which is again a very important scientific heritage of our country. Typically, when we hear Chandas, we associate it with poetry. That's what comes to our mind immediately. Okay? But after perhaps 10 minutes, I will tell you how this can be a fertile place for mathematical innovations. Okay? So, with due respect to your knowledge on Chandas, I will still take you from the scratch very quickly what Chandas are. So, it basically has to do with Laghu Akshara and Guru Akshara. And they are also classified in a very scientific manner. That which takes a shorter time is a Laghu Akshara. That which takes a longer time to deliver, that's a Guru Akshara. For instance, all the Harsva Aksharas are Laghus by convention, and all the Dirgha Aksharas are Gurus. But an exception comes if a Harsva Akshara is followed by a Samyukta Akshara. For instance, here two words, Kula and Kumbha. you try to pronounce it in your own mind, you will see that the time taken to pronounce ku in the kula will be almost half than the time taken to pronounce ku in kumbha. Kula, kumbha, because that half ma sound also gets added to the ku while pronouncing it. Hence, ku, being a harsvakshara, is still taken as a dirgha, as a guru. There. So that is one convention that you need to keep in mind. So with that harsva and dirgha, sorry, I didn't show the word. So this is kula and the kumbha, that already gave the example. So if you look at, there are two types of chandas. First, let us look at this matrika chandas. What does matrika chandas means? It's there even in Malayalam also. Unfortunately, I don't have any Malayalam example to show. That's why I'm just showing you one popular Hindi example. What here you do is, you fix the number that adds up. You associate, this is a Laghu Akshara and S is a Guru Akshara. You associate 1 and 2 to Laghu and Guru respectively. So if you add up this entire thing, it will add up to 16. So in any of these 4 lines, if you add up, they will all add up to 16 in each line. But if you see here, the distribution of Laghu and Guru are random. There is no specific order in which Laghu and Guru are distributed. Right? All are with me till now? Here, then the Chandashastrakara asks the question. If I, now what you see as here 13, what you saw in the previous slide as 16, here if you do it add up, I mean I can add it for you. So there are 4 ones, 4 plus 2, 6, 7, 9, 10, 12, 14, 16. So like that if you see it, there are 3 gurus and remaining are Laghu, so it has to be 16. There are 4 gurus here, so 4 twos are 8, 10, 12, 14, 16. So these are all what I call it as a numeric value. Okay. The question that the Chandashastrakara asks, having fixed the numeric value, in what are all the combinations in which the Laghu and the Gurus can occur? That's the question that the Shastrakara asks. So how it builds up? 1 is a very trivial case, because if I fix the value as 1, I can only achieve 1 by 1 Laghu. If I fix the value 2, I can have 2 Laghus or 1 Guru. And those 2 Laghus, if I have 3, it will be 3 Laghus or 1 Guru and a Laghu. But when you have 1 Guru and a Laghu, the sequence also matters. Right? Whether it is Kala or whether it is Kala. Because Kala and Kala both have the numeric value 3. But one in Kala, it is Laghu followed by a Guru. In Kala, it is Guru followed by a Laghu. Right? So that also matters. So like that, if you see, if you fix the numerical value and you ask a question, how many such possibilities are there? And these are the total possibilities. What do you see here? What pattern does it seem to show? You see a pattern here? If you take, say, 8. 8 happens to be 5 plus 3. Similarly, 13 happens to be 8 plus 5. 34 happens to be 21 plus 13. So any n you take, it is n minus 1 plus n minus 2. And what do we call that sequence today as in the textbook? Your Kerala textbook also has got that name. I think this comes in class 11th, class 12th. But this whole concept doesn't come this way, but the sequence comes. Any guess you would like to make? This is indeed an arithmetic progression, but there is a specific name associated to this arithmetic progression, which our own textbook writers are now taking pride by calling it that particular name. Sorry? Exactly. There you are. This is called a Fibonacci series. Fibonacci series attributed to an Italian guy called Liber Abaci. Abaci is the name of the village. His name was Liber. So this is associated to Fibonacci series. But this was given by Pingala, explained by Hemachandra. Pingala came at least 1,000 years before the Fibonacci was born. Liber Abaci was born. And Hemachandra was at least 500 to 600 years before Liber Abaci. But what do our textbooks say? This is Fibonacci series. Neither Pingala series nor Hemachandra series. But this is there in Chanda Shastra through this way that I have shown you. In the Chandas context also, what I showed you was a Matrika Chandas, where the numeric value was fixed. There is something called, another variety called the Varnika Chandas, where Varnas are given importance and not Matras. Okay? Let's see what kind of a mathematics emerges here. This consists of unique combinations of again laghus and gurus. Mind you, here it is unique combination, not just any random combination. What is fixed is the number of syllables per quarter is fixed. Unlike in the previous where the numeric value was fixed, here number of syllables per quarter is fixed. Okay? Then the Shastrakara asks the question, given the number of syllables in a quarter, there exists how many combinations of laghus and gurus corresponding to that particular number? That will be made clear if I could show you an example. There's again a very famous Varna Chandas called Bhujanga Prayati. The way you pronounce itself, the Chandas, the Lakshana of the Chandas comes out. Bhujanga Prayati. Okay? So in the same metrical pattern, you can chant this. Nama, Misha, Mishana, Nirvana, Rupam. Right? And I have divided that into 3 bits because each bit is called Nava Gana. That's how the Varnika Chandas gets defined. If you look at each Gana, Namami is one Gana, Shamisha is another Gana, Na Nirva, Na Rupam. Mind you, when you are splitting it to form Ganas, it will not have a linguistic meaning. So I am not doing a Sandhi splitting here. I am doing a Gana splitting here. Just to say that the number of syllables per quarter is 12. So this becomes 1 quarter. Namamisha, Mishana, Nirvana, Rupam. Here 1 quarter. So the number 12 is fixed. How the 12 is achieved? So 3 here, 3 here, 3 here, 3 here. 3 fours are 12. But again, what do you see a pattern in this 3? It is Namami. In terms of Laghu and Guru, how it is? 1 Laghu followed by 2 Gurus. Laghu, Guru, Guru. Right? So the entire Chandas can be defined in a very beautiful way as it is. Ta-tum tum, ta-tum tum, ta-tum tum, ta-tum tum. So if you have the proclivity to compose the poetry, if you just have that rhythm in your mind, then you can start composing it in this field. So there are lots of examples of Bhujanga Prayati, but my goal is not to explain Bhujanga Prayati here, but my goal is to say that the number of syllables fixed in the pada is 12, of which one example is 1 Laghu followed by 2 Gurus, that becomes Bhujanga Prayati. But is that the unique one? No. Because if I show you the next one, this is Totaka, which also has got 12 syllables per quarter fixed. But how the structure here is, it goes Vidita, Khila Shastra, Sudha, Jaladhe. So how is it in terms of Laghu and Guru? Vidita, like it is Laghu, Laghu and a Guru. Ta-ta-tum, 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 ta-ta-tum. Unlike the previous one, it was ta-tum-tum, 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 ta-tum-tum. Here it is ta-ta-tum, ta-ta-tum. You can see the metrical variation that itself gives you, because of which you get a new chandas getting formed. Are these two the only unique with the 12 padas, 12 syllables in one pada? No. You have another Shrigvini. This also is very popularly known. How does this meter follow? It has got Guru, Laghu and a Guru. Achyutam, Keshavam, Ramana, Rayanam. Tum tatum, tum tatum, tum tatum, tum tatum. What I am trying to show you is, just with 1 Laghu and 2 Gurus, you can get at least 3 different varieties. The Shastrakara asks here, are these the 3 only thing? If I fix 12 syllables per pada, how many such combinations I can get? That's the question that he's asking. Today we know to immediately answer it as what? Even if you have not studying Chandas, it's like saying I have 3 things to pick. Sorry, I have 12 things to pick. How many such possibilities I can have? Immediately the answer will come out as 2 to the power 12. Right? So he is asking the same question. Answer to the Shastrakara's question is, there are 2 to the power 12 such possibilities. How to compute them? How to list them? Because 2 to the power 12 is a huge number. First of all, how to list them in a systematic way. And having listed them, make sure that you are not repeating the one pattern again and again. You are not counting Bhujanga Prayati twice. Right? And so you sequence them. Then somebody asks, the Guru asks, okay, tell me the 64th entry in this. You should be in a position to immediately go to that 64th entry in your mind and come out with that Laghu Guru pattern that appears in the 64th entry. Or this is called Uddishta. The Nirdishta, I give you the 66th pattern and ask you what is the corresponding number to it. You have to tell the number. These are all happening mentally, not with some, today, I mean, without a laptop, I can't even talk today. But these are all happening in the mental level for 2 to the power 12, imagine. Definitely we cannot do it with 2 to the power 12. So I can give you the example of 8 at least. Or no, not even 8, 3. Instead of fixing 12 syllables in one pada, let's fix only 3 syllables in one pada. There are no legitimate composition which can be composed with just 3 syllables in one pada. But for our fictitious example, I'm taking just 3 syllables in one pada. We know the answer is 2 to the power 3, which is 8. What are those 8? Those 8 are all the 3 gurus, all the way till all the 3 laghus. Right? So here Pingala gives a very systematic way to even list them out. I'll not bother you to, otherwise it would be a good exercise to take a piece of paper and do it step by step. What he says is, this is a procedure to at least to first list them out, all the possibilities. In the case of 3, it is very easy, 8 are only there. But in the same case of 12, 2 to the power 12, listing out the possibilities itself is a daunting task. So first he gives a recipe to list them out. The recipe is very simple. Suppose you take, say, value 4. So 2 to the power 4 is 16. What he says, first write all the 4 as gurus. Then you proceed to the left extreme. If there is a guru, write as a laghu and copy the rest as it is. Again, for the third iteration, go from the left. And if you encounter a guru, first guru, write a laghu below it. Copy everything after that as it is. When you come to the one empty place, toggle opposite of what was in the previous entry. Like that you keep proceeding. So like that it generates all the 16 in a very systematic algorithmic way. So these are those 16 entries that you have. You start from all the 4 gurus and you stop coding, code for your thing is all when you hit all the laghus. And systematically if you follow this, you will not do any error. So the Uddishta, the Nashta and the Uddishta problem is, suppose I give you here say LLLG. I want you to find out the number. You should be in a position to quickly say this corresponds to the 8th entry. And I say, what is the 12th entry? It is LLGL. So Nashta and the Uddishta problem are also equally addressed here in this aspect. But what is the beauty about it? Now you associate with Guru as number 0 and Laghu with number 1. Okay? This is not a value for adding up like 1 and 2 in the case of the Matrika Chandas. No. Here, just for representation's sake, you associate Guru with 0 and Laghu with 1. And corresponding to these 16 entries that I have shown, you write them in terms of zeros and 1. So all the 4 Gurus are written as all the 4 zeros. Then Laghu followed by 3 Gurus. So like that. And because Anka Naam Vamato Gatihi, you take a mirror image of them. Just a mirror, this is the mirror image of entries 1 to 4. What do you actually see them? They are the binary representation of the decimal numbers. So all of us may recognize 2 is written as 1 0, 3 as 1 1. Similarly, at least till 15 you have this binary representation of these decimal notations. So this is what actually Pingala is doing. But what was his original question? He was bothered not to compute the binary representation of 15. He was bothered with, given a particular syllable, number of syllables in a pada, how many laghus and gurus combination I can have, degree of freedom for me to compose. A question from or originating from what domain is giving us answer in which domain. I mean, luckily for us, now NEP is talking about this kind of cross-disciplinary approach. Okay, so much for that. This you will find. There is a chapter in Brihat Samhita by Varahamihira, chapter on Gandha Yukti. There he talks about how to prepare different fragrance of perfumes using 4 base perfumes. It's a whole chapter not on actually Gandha Yukti. The title is Gandha Yukti, but the chapter is on permutation and combination. Purvena gatena yuktam sthanam vinantim pravadanti sankhya. Like that it goes. I mean, how do you construct a meru so that ultimately you get a 16C4. those of you understand this permutation combination language, 16C4 is 16 factorial divided by 4 factorial times 12 factorial. So you compute that, that recipe we get it in Brihat Samhita's Gandha Yukti chapter. So this cross-disciplinary approach, that is what we directly see in these kind of texts and deliberations. Time is up. No, this was just a listing out problem. Still he has not computed what is 2 to the power 4. Okay, that computing comes from here. Virardhe rupe shunyam dvishune tavadardhe tad gunitam. That's all. This is a Chanda Shastram recipe for computing 2 to the power n. But the problem is, like with every century, Pingala had written it in way back, I think before the Common Era. The language became so obscure. It was a very cryptic language that we needed Hemachandra, who had to come after 600 years to come and explain them. So what we are facing today is not a unique problem. It has been the problem in our civilization for quite some time. So Hemachandra comes and explains it. Of course, he doesn't explain it in English the way I put it here. He explains it in his own way. But the sara of that is, you have to do this. Like if you take the example of 12, you divide, if it is divisible by 12, you write 0 somewhere. 12 is divisible by 2, so we divide and write 2. Like that, there is a recipe to be followed. And ultimately, if you do it, you are able to get this 2 to the power n, given any n. And this has got repercussions in terms of the convergence of this series, the rate at which you can compute. One of my colleagues works on, and he has shown that, of course, not for 2 to the power n alone, but to show one of the Madhava series, how the rate of convergence is much, much different, much faster given by Madhava than compared to a French mathematician. So just to impress upon you, the fact is that the rate of convergence, people have worked on it, and they have shown that the 2 to the power n, not the convergence in this case, the rate of computation is much faster in the case using this algorithm than the other algorithms which are being used. So again, one more example of, again, Chanda Shastra, Meru Prastara, but I'll not bother you with the details here. This Chanda should be enough. But what I would like to draw your attention is this particular sentence alone. This is the 8.34, and 8.33 also is, no, or 8.35. Pare Purnam iti. That's all. The two sutras come one after the other. And we needed really Hemachandra to come and explain it, what these two words actually mean. Pare Purnam iti. There are two sutras, mind you. Actually, it turns out that they are, today we call them in our textbook very proudly as, louder? Sorry? There, but whose name is associated with it? It's a Pascal's triangle. We are proud because we are proud inheritors of Blaise Pascal and not Hemachandra or Pingala. So this is actually coefficient of binomial expansion. So if you have a plus b the whole power n, all of you may understand a plus b the whole power 2. So a square plus 2ab plus b square. So a square has got a coefficient 1. AB has got a coefficient 2. B square is 1. So 1, 2, 1. So if it is 3, it is a square plus 3a square b plus 3ab square plus b cube. So 1, 3, 3, 1. So they are called the coefficient of binomial expansion. And this is what is Pingala trying to give us through this Pare Purnam iti. 1, 2, 1 is a plus b the whole square. 1, 3, 3, 1 is a plus b the whole cube. Like that. I have not given you the connection to Chandas or poetry here because that will take still longer. But this is all coming from questions asked in poetry, mind you. Okay. I'll switch gears now. Then I'll come to the field which I'm little more familiar with than the maths. I'll straight away take with iron, actually. With respect to iron, today we take, in our textbook, we have only example of the Delhi iron pillar which never rusts. In the morning we were talking of Dr. Gopalakrishnan, and in his lecture he'll always say this. He adds a joke to it. It has not rusted even when it is standing next to the parliament. So this is his statement, okay, and he puts it in a very characteristic way, his own characteristic way. So iron metallurgy is a very interesting thing from our country. And these are the geographical places where I have taken from this book, Panchanand Niyogi's monograph on iron metallurgy, which was published almost 110 years back. But the point that I'm trying to highlight here is whether it is north, south, east, or west, the archaeological excavation that we have got in the last 100 years are having similar iron constituent, which means the technology to make was widespread and was more or less uniform. See, it is not that somebody sitting at one corner of the country had chanced upon the making of iron and he has never bothered to share the knowledge with others. It has become like a kula practice for that particular thing. At least archaeological excavation doesn't show that, because the archaeological excavations are more or less uniform from Delhi to Kanyakumari. By the way, although it is Delhi shown in this map here, this is referring to Delhi Iron Pillar, but this was actually somewhere here in a place called Vishnupadagiri. And we all know that when Kutubuddin Aibak came, he plundered the temple of Vishnupadagiri. He uplifted that iron pillar, took it to Mehrauli, and his successor, Iltutmish, he kind of constructed a minar in the honor of his predecessor, Kutubuddin Aibak, which is what we call today as Kutub Minar. And this Delhi Iron Pillar stands as a testimony in that particular complex. So the art of making rustless iron is widespread in the Indian context. At least other than Delhi Iron Pillar, those of you interested to know, you should look at the Dhar Iron Pillar in Madhya Pradesh, the Konark iron that is kept in the Bhubaneswar Sun Temple, just lying outside, because when the temple the main mandapa had collapsed almost 120 or more than 120 years ago, the iron beams that were used in the construction were all taken and kept out and lying in the wilderness exposed to the climate for more than 100 years, but they have not rusted yet. Then close to this place, there is a place called Kollur, Mukambika. There also there is an iron pillar which has not rusted. But now in the past 5 to 6 years, there are papers which are coming out and saying that a pillar has started to rust. And it's like people were waiting, when this pillar is going to rust and when they are going to come and write a paper on it. So, of course, I told you about the iron pillar part. The Damascus sword. Damascus is a place in Syria, and this is called Woods steel. Woods is, by the way, not the name of any person. Woods is an anglicized version of the Indian word called Ukku. Ukku comes from Tamil Urukku. In Malayalam also you have Urukku, the same word with the same sense. So steel making has always been a very non-trivial task in whichever civilization had tried it. When Britishers couldn't make it even 200 years till back. It is said that Michael Faraday, about whom we learn a lot in the textbooks, one of his unfinished project was to make steel which could match the quality of the steel coming from India. And it failed. So although Faraday is credited to make nanoparticles, and the gold nanoparticles which are displayed even now in the Royal Museum, but his attempts on making steel are not widely known. So the Woods steel is one of the very important steel. Steel, by the way, is iron plus carbon. Essentially, iron and carbon constitute steel. But that carbon has to be of a very, very specific proportion. Very narrow window of 3 to 5%. Not even 3 to 5, it is 3 to 4%. Anything less than 3%, it will be the pig iron. And anything more than 4%, it will become brittle. It will not have that kind of durability. Because after all, the sword has to be used in a battlefield. It has to cut many heads as possible. It's not that one head it is cut and we go to start sharpen the sword, right? So sword has to last as long as the enemies are there in the battlefield. It has to be, and it has to be also very lightweight. If the entire effort goes in only taking out the sword and killing it, and that man collapses while killing the other, purpose is again lost. So it has to be very light in weight. It has to be sharp. Sharpness has to get sustained. So that was all the qualities met by this Damascus sword. So made out of wood's steel. Steel making has been so much of preoccupation in this part of in this country that this picture beautifully summarizes it. It's not a photograph, by the way. It's an artistic impression of the interaction that happened between Alexander and Puru in the northwest frontier. So the person he is Alexander, he is being given a sword by Puru. And something very important that what I want to draw your attention is this particular fellow. He is one of the helper, and what he's holding in the hand. At least what can you see it? It appears like a golden box. It's a gold box. What is kept inside it is more interesting. It's a brick of steel. A brick of steel is gifted to Alexander by keeping it inside a gold box. Today, even if we buy a mukuti, we go to the bank to keep it inside the iron safe. Even a gram of gold ornament today will be kept so safely in such bank lockers. But that was the case. Steel brick kept inside a golden box and gifted to Alexander. Anyway, moving on to other metals. Copper, another very important and a very strategic metal. So much strategic that you may realize few years back there was a big uproar in Tuticorin, Thoothukudi, and where the copper factory was made to close a few years back, not many years back. It was 5 or 6 years back. Right, Sterlite copper that was made to close, and because of which now we end up importing copper from raw material from Pakistan and finished copper from China. So this is not a very old history. So copper is one of the very strategic metals, even back then and even now. Why strategic metal? Because electric conductance. The entire electric conductance happens through copper. I mean, it could have happened through gold, but then we are not as rich, and gold deposits are not that plenty. Luckily, copper is serving that purpose. So anything to do with supply of copper will hit the economy very hard. We were so much proficient in extracting copper that we made a colossal 8 feet tall standing Buddha statue out of it, which has not got corroded. It was excavated somewhere in 1850s from a place called Sultanganj in Bihar, and now it is still preserved very nicely in Birmingham Museum. So more interesting than copper is the alloy, brass. Brass, as you may all know, it is a combination of copper with zinc. And in the context of brass, there are two brass that are normally discussed. One is called accidental brass, and one is the intentional brass. What is the difference? When you smelt copper from its ore, accidentally the zinc ore also gets processed along. Not intentionally, but accidentally. So when such accidental mixing happens while smelting, you end up getting an accidental brass. But where people have found that the zinc percentage cannot be more than 15% in that accidental brass. But in Indian context, they have got brass where it contains 30% of zinc, which is only possible if you can mix pure copper and pure zinc and make that kind of a brass. Okay. Brass is also a very enigmatic metal, enigmatic alloy, and it has got, like every other metal, various names, which has confused historians of science, like Riti, Ritika, Pitala, Arakuta, Ara, Swarnaka, Krita, and we find lot of, and this question of who first made brass intentionally is not a very trivial question. So much so that this lady, Vanda Morton, was behind it, and luckily, very recently only this was published, as recent as 2019, and it is now very clear that it was in India that the intentional brass was being made in a huge amount, and for the very first time. So, Tadaha Vaishvanaram Pittalam, we have lots of textual references from ancient till medieval times to show the provenance of copper, brass. I will not bother you with from Katyayana Shauta Sutra, then again from this Shauta Sutra text that you get this. Different words are being used. Swarnakrita is a synonym for brass. But again, I wish to here make it very clear that today we understand the process of making alloy through phase diagram. I am not at all claiming that right from the Shrauta Sutra or the Atharva Veda period, Indians knew phase diagram or Indians invented phase diagram. That is not my claim at all. They had made alloys, that much we know. But how did they make alloy? We do not know. Today we understand it in the language of phase diagram. So please don't get me wrong when I say that the Indians were the first to invent even the phase diagram. That is not my claim at all. Bronze is another very beautiful alloy. It has got the mixture of copper and tin, something that all our textbooks had this dancing girl from the Harappan period. To even now, if you go to, your own place, here also bronze are very famous. Swami Malai is what is normally the Chola bronze are made. Even to this day, they follow the same technique, which is called the Madhu Uchishthana Vidhi. But unfortunately, our textbooks just call it as lost wax method. So, but the actual methods name described in the Shastras are Madhu Uchishthana Vidhi. Zinc, in that sense, becomes very important. In Malayalam also, you call it as Tuttanagam or Tuttam. But unfortunately, in the Tutta has got a different connotation in Ayurvedic texts. Copper sulfate it becomes there. So such kind of naming standardization, because we have lost the language culture now, so the word Tutta becomes quite enigmatic now. So much so that in Arthashastra, in the second Adhikarana, while processing silver, the word Tutta in the same verse appears for almost 8 times. And it's not very, I had not by-hearted it, but I am not able to recollect the full thing. Asti Tutta, then Samatutta, Sisa Tutta, like that. There are 8 times the word Tutta appears, and we are not in a position to give clear explanation to that word, what that Tutta means. But generally now today, Tutta in the parlance means in both in Malayalam and in Tamil as zinc, Tuttam, Tuttanagam. In the Chinese, interestingly, the zinc is referred to as Tutanag, and the Madanapala Nighantu also has got a different name, Jashada. Jashada comes because of the original word Yashada. You have Yajayor Abheda. So Yashada, Yasham, Dadati iti Yashada. It is as bright as silver. So Yashada becomes Jashada, Jashada, Jasadam. And today in Hindi, in the North Indian local parlance, it is Jasta. So there are different names to it, but the important part to the zinc is we can proudly say that India has been the first ever manufacturer of zinc at its highest quality from a very, very long time. How did they make it? It's also very interesting. Essentially, chemistry happening is that you have to reduce zinc carbonate and convert that zinc carbonate to zinc. So you do it first, remove the carbon, then you remove the oxygen. But when you get it to the zinc level, it is so problematic that the liquid zinc has got a tendency to easily vaporize. It doesn't percolate down very quickly. So if you are smelting zinc with this process in an open furnace, you will not end up getting the zinc. So you will end up losing the zinc as zinc vapor in the atmosphere. So, so they invented very indigenous apparatus for that called Vrintaka Musha. This is also very interesting because we have to see Vrintaka is normally translated as brinjal, but we'll have to again sit with the Ayurvedic people and see when was this introduction of brinjal happens in our vegetable list. Because brinjal, to the best of my studies, are very recent. Recent in the sense not before 1500 or 1600. But then definitely the Granthakara here would not have intended a brinjal shaped musha. Vrintaka would mean something else. That is for us to sit and clarify. But the indigenous part is they invented something, a closed furnace system, where you put a top pot filled with the raw material and the required carbonaceous material with a small perforation, tilt it upside down and place it above an empty pot below the ground. You heat it from the top so that the reaction happens and the zinc from zinc carbonate gets converted to zinc, melts, doesn't escape out, but due to action of gravity comes down, and due to temperature gradation, the vapor condenses. That's how you get pure zinc. Archaeological evidences are found near Jhavarmala mines in Udaipur, Rajasthan. And this Paul Craddock, who was also awarded the Padma Award by our government of India, he had done elaborate work on the zinc provenance in India. KTM Hegde was the Mangalore University professor. He had some connection with Kerala also. They have finally concluded, and I ironed it out, saying many tens of thousands of tons of zinc was produced. Okay, and this is the earliest dated zinc mines in the world. So earliest known center for zinc production. So something that we can surely be proud of, and especially when a foreigner has given the endorsement. Textual examples. What I mean by textual examples is again to show the scientific temper with which these texts were also written. Now I'm not going to show you the entire text, but give you some glimpses. This is again from Arthashastra, where just concentrate on this sentence. Sthalapathe api haimavato dakshinapathat. There's some error here. It's not this how it should appear. I mean, it should. Pathat Shreyan has. Okay, whatever it is. There's a font change that is happening here, and it's very difficult to read from this script. This script is easier. The point is, Kautilya is trying to write and trying to say where are the gold deposited. He writes in the sentence that Haimavato Dakshinapathat Prekshan. If you go towards the Himalayas or if you go to the Dakshinapath, towards the southern part. So somewhere he is placing himself in the Vindhya region, okay, or in the Bihar region. And he says if you go towards the Himalayas, there you will find the gold deposits. And if you go to the south part also, you will find gold deposits. And indeed there are Kolar gold mines are in south, and then you have Golconda, also you have a lot of gold mines there. But the most important part is Neti Kautilyaha. So this is, when he is writing it, writers before him did not consider going to the southern part. So he contradicts the previous writers and says, I do not believe it in this way. I see that if you go to the south part also, you will have gold deposits. And this is there in the text. For somebody to go against their predecessors and write it, is he not questioning their behavior and kind of changing it? I mean, is it not an example of, again, scientific temper there? Again from Arthashastra, but I would like you to just concentrate here. Lakshanadhyakshascha chaturbhagatamram rupya rupam tikshna trapusisanjanana nana manyatam. Okay, so the point is, the bhagas are more important here. Chaturbhaga, Ashtabhaga, Ardhamashaka, Ardhakakani. Okay, they are actually measures. What I'm trying to drive home the point is, they are either 1/16th part, 1/4th part, again 1/16th, 1 pana. So think of a society having such kind of numerical accuracies. And when you talk of numbers, number is same like you and me. I mean, it cannot have a subjective approach. So standardization has to happen for those numbers to become universal. So can that happen without even thinking or without even having a scientific thought process? That's for that reason I had shown this particular thing. If you look at the Rasashastra text, this is from the Rasarnava I have taken, and it says it is a Chaturtha Patala. What are the first 3 Patala? Those of you who are interested, you can go out. This is available in public domain. The first chapter is all about, the first 3 chapters are all about mantra, and then about the qualities of student, quality of a teacher. Then the 4th chapter onwards, the actual text starts. Unfortunately, the biggest name which had first translated this work into English ignores the first 3 chapters and starts only from the 4th chapter. Okay, so inspired by that intellectual giant, I am also showing you only the 4th chapter. So the 4th chapter, how does it begin? Yantra mushagni manani nagnatva mantravedyapi Kim karoti Mahadeva tani me vaktum arhasi. The entire Rasarnava is written as a dialogue between two people. The people's name is Bhairava and Bhairavi is what is attributed. So this is Devi is asking. So Yantramushagni Mahanani Nagnatva Mantravedyapi Kim karoti Mahadeva tani me vaktum arhasi. So she is saying, without having the knowledge of this yantra and the musha, what knowledge will I have? Okay, you have given me the knowledge about the mantra, the qualities of student, qualities of teacher, fine. But without the knowledge of all these things, how can I proceed? So which means, see the fervor with which the text is being introduced. The importance given to the yantra, the tantra, the experimental procedures here. By the way, this context I should also caution you that many of the words that we use are like in English also. For instance, the word field. To a mathematician, a field would mean something else. To a physicist, an electromagnetic field is meaning something else. To a farmer, a field is something else. But the word is field. Similarly, in the Indian context also, for technical texts, the words have a contextual meaning. Tantra is not everywhere the same tantra with which we understand, like the Buddhist tantra or yantra. It has got its own connotation in that particular context, how to read it. That's where the Tantra Yukti comes in to help to understand those contexts here. Why I'm narrating this is, last month in a talk there was a very interesting question. The question is really interesting. Because everybody knows Vata, Pitta, Kapha. Vata is typically in English understood as air. Vata is air. The question was, very curious question was, what is the effect of the monsoon, which is the Vata of the Loka, to the Vata of our body? I mean, to me it was like a out of the syllabus question. Because for me, clear misunderstanding of the word Vata and getting carried away by the word English translation as air alone. Okay, so that's why it is more important to be contextually rooted when you say when you use certain words. Because talking to Ayurvedic people will tell you actually Vata, you have to understand it from a Ayurvedic perspective. Movement. I mean, it has got to do with movement. Anything can move. I mean, not just wind will move. Anyway. This again in the same Prasarnava, this is actually very beautiful instance, which is the first ever documentation of the salt analysis flame test that we do in the school. So in the high school science students, when you were in high school or when your kids are going now, you'll see that in the chemistry lab they will have a practical on flame test. You introduce this particular salt, the flame color will change to this, right? So this is the first ever documentation of the flame test. Avartamane, Ganake Pita, Tare Sita Prabha, Shulve Neela Nibha, Krishnavarna Sureshwari, Vangejwala Kapotabha. So there's a metal name and then the flame's color name that it is going to change. Ganake Pita. Tara is silver, Sita is white, Shulva is copper, by the way. And interestingly, the word sulfur comes from Sanskrit. Shulvasya arihi iti shulvari. The shulvari becomes the sulfur that we still use today. So shulva is copper, shulva, and that imparts a blueness to the flame. Tikshna is a kind of iron which imparts a black. So Vanga is tin. But there are some confusion. Some people read it as lead also. Like that, there is a description of this experiment. Do not bother. There are qualitative checks given to say if a process is completed, how to be sure that the process has been done to its logical completion. They give qualitative checks and balances. So I'll not bother you with that. There was some biology. I see that I have 10 more minutes left, right? Which I would like to use for more interaction rather than giving it here. With just a few closing remarks, although I had something the way forward also, but I will not bother you with that. With this scientific temper, obviously we generated wealth. We did not do this for the sake of only for intellectual curiosity. On the one hand, we needed to maintain the health of this society, and we needed to generate the wealth also. In our system, there was no taboo to generate wealth. It's an Upanishadic statement that annam bahukurvita, tad vritam. Whatever you do it in plenty, but don't just hoard it for yourself. It has to be distributed. So that obviously attracted our invaders or our attackers as well as our traders, because of which the economy gradually went down. So this is what William Ramsay had to say, that a country which is in advance of the rest of the world in chemistry will also be foremost in wealth and general prosperity. Because he was a Nobel laureate in chemistry, so he said this with full confidence and conviction. And that you correlate this with this Angus Madison's data, which gives you the world GDP, contribution to world GDP by 5 different prominent countries. And you see, for more than 1.5 millennia, India and China were the leading contributors to the world GDP. And that could have been only possible with this proficiency that with which we had it in metallurgy, material science, chemistry, engineering science. And that all could have been only possible with the scientific way of thinking that we had sustained it all along. So, but where did we go wrong? Today, it's very unfortunate that if you see the Palampur declaration or the analysis that people draw of why did we go wrong? Okay, we were so great at once upon a time. Why did that greatness completely stop? Why? Because Shankara gave Mayavada. Because of casteism in our society. These are the two things that our detractors always attack. I don't want to take names, but some of the very famous names who are Padma Vibhushan awardee have gone in public and written about such things. But I beg to differ with them, and through this analogy I wish to express my differing thoughts. It's a very thought experiment that was conducted, that some scientist, he took a frog, he kept it on the experiment table, set the frog to jump. The frog jumped. Then what he did, he cut one leg. Frog was alive, and with the 3 legs, the scientist asked the frog to jump again. The frog jumped. Then like that he cut all the 4 legs. The frog was alive. Now when the 4th leg was also cut, the scientist said the frog to jump. Obviously the frog could not jump. What did the scientist conclude? On cutting the 4 legs of the frog becomes deaf. Okay? So there are problems that we need to address, for which we need to apply logic and attribute the reasonings to it. So that is very important, because I have put it under the question, why did we err? There are several reasons on why we have erred, but just to come to a generalization in a very baseless, absolutely illogical way is not scientific at all. It's not a representation of scientific temper at all. Way forward, I'll really not bother you, because this is what I wanted to show was, I'll just stop at the summaries. One of the preparations that we took up, that is Lauha Bhasma counterpart in the Siddha, from the Siddha thing, we said, okay, let us try to prepare it and see whether we are getting the same properties that were, what is actually happening to the iron raw material that is being subjected. So when subjected to these kind of tests, ultimately what we conclude was that there is a core shell nanoparticle forming, core of iron and shell of silicon dioxide. The silicon dioxide is coming from the quartz that is there in the iron ore. Now these herbs that are getting added to while preparing Lauha Bhasma are lowering the temperature, because the melting point of silica is 1500 degrees Celsius. But in the puta, or the furnace in which this bhasma is prepared, has maximum we measured could reach only 900 degrees Celsius. But still that silicon has become polysilicate, which means there is the herbs that were added are helping in reducing their activation energy for conversion of silica to polysilicate. That was our conclusion here. I'll not bother you with this. Again, I'll stop. This the last slide of my presentation. I'll not bore you, I'll not hold you longer. My very favorite slide, because I feel like reiterating this again and again, no matter if this may be repetition to some of you. C.V. Raman, Nobel laureate, he was invited by none other than Rutherford. Rutherford, the famous gold foil experiment guy who discovered the presence of nucleus. So Raman went to Cambridge, toured around, was very disappointed. He said, that's what his quotation is, Cambridge is a place for play and not for study. Why did he say that? Because he saw people, students involved in all sorts of activities, other than just reading and writing, music, dance, sculpture, whatever it is. So that gave an impression to him that perhaps Cambridge is not a place for serious study. But more importantly, what was the reply by Rutherford? We do not try to grow bookworms here. We train men who can govern an empire. So through my presentation, I tried to show what was scientific temper with which we were doing. We erred, something happened in the middle, we lost the track. There is now resurgence happening. So let's aspire to again get back to that mode of training people who can govern empire and not just convert them into bookworms. Okay? So with that, I once again thank the organizers for giving me this wonderful opportunity. And if you have any question, I'll be happy to take them up. Otherwise, thank you to all.
Thank you, V. Ramanathan sir, for sharing your valuable knowledge. Now, I humbly request Brahmachari Achyutamrita Chaitanya to honor Dr. V. Ramanathan with a token of gratitude. Welcome both.